Hi everyone, in this video we're going to continue our look into right triangle trigonometry and check out a few more of the fundamental identities. So we're going to start with an investigation into the Pythagorean theorem. We know that the Pythagorean theorem relates the legs and the hypotenuse of a right triangle. So if we call A and B the legs with C the hypotenuse, we should at this point know A squared plus b squared equals c squared. Again, it's important to note that A and B are the legs, C is the hypotenuse. So in math class, mathematicians, not in math class, but one of my favorite questions, one of mathematicians' favorite questions is, what happens if I do this? And that's, I think, the basic fundamental question in discovery is, what happens if I do this? And so what happens if I divide both sides by c squared? I don't know why, I just feel like it. I'm feeling a little adventurous. So I want to divide both sides by c squared, just because what happens if I do? All right, so what does happen? Well, I get a squared over c squared plus b squared over c squared equals 1, which is kind of exciting because what's a squared over c squared? Well, if I'm over here at A over c looks a lot like opposite over hypotenuse, doesn't it? So a squared over c squared is basically a over c squared, and a over c is the sine of a, isn't it? So if we call this a theta, wouldn't this be the same as saying sine squared theta, the sine of theta squared? And similarly, this is b squared, b over c quantity squared. So isn't b squared over c squared the same as saying the cosine squared? In which case, what's kind of crazy about this is in any angle, the sine squared plus the cosine squared is equal to 1, according to the Pythagorean theorem and the question, what happens if I do this? So how can I, come up with some examples of that? Well, again, let's go to our calculator. Pick any random angle measurement. Again, I'm going to go to degrees because degrees feel better about being in a right triangle. But basically, let's do the sine of 50 squared. A little notational thing, I'll discuss that in a few minutes. But just understand that sine of 50 squared is different from sine of 50 squared, right? Huge difference there. And notationally, we write that like this: sine of 50 pause squared would be written as sine squared of the angle. You can't do that quite like that in a calculator, though. So sine of 50 squared plus the cosine of, again, that same angle, pause squared, and you get 1. Pretty crazy. If you choose another angle, again, this should work for every single possible angle imaginable. So 47, again, I'm just making these numbers up, just riffing here. Cosine of that same angle, 47, close that parenthesis squared, you're going to get 1. And what that's saying is there's a basic relationship between the sine and the cosine of an angle, and that's called the Pythagorean identity. And the Pythagorean identity says, it's on your reference sheet, that the sine of an angle squared plus the cosine of that same angle squared will always get you 1. There are a couple of other forms of the Pythagorean identity. Here's the second and the third forms of the Pythagorean identity, and we're going to derive them. So I want to take the basic form of the Pythagorean identity, which is sine squared plus cosine squared equals 1. And I want to derive the other forms of the Pythagorean identities. And to do so, again, you're going to return to that question, what happens if I do this? So what happens if I divide both sides by cosine squared? So let's try it. What happens if I divide both sides of this identity by cosine squared? Well, we get sine squared over cosine squared plus cosine squared over cosine squared equals 1 over cosine squared. And now let's simplify those. Sine over cosine looks an awful lot like tangent. So since they're both squared, we're going to have tangent squared. Anything divided by itself is 1. And what's the reciprocal of cosine? You got it. It's secant. So what happens if I divide both sides by sine squared? Why don't you pause the video and find out yourselves. Hopefully you got something along these lines. If you divide both sides by sine squared, you get sine squared divided by itself is 1. Cosine squared over sine squared is, of course, cotangent squared. And 1 over sine squared, the reciprocal of sine squared is, of course, cosecant. Now, what you should have is all 3 of these from your reference sheet with a little bit of proof, a little bit of how each one is derived. So the first one comes directly from Pythagorean theorem. The second one comes from dividing both sides by cosine squared. And the third one comes from dividing both sides by sine squared. So what do we do with these? Well, we can take a look at the next couple of problems. Parts 3 and 4 will allow you to compute values based on one value rather than having to always revert back to your right triangles. So take a few minutes and see if you can come up with any of these on your own. I'll walk you through number 3, and then again. So what you're going to want to do here is, if we know our sine is 0.6, we want to find the value of cosine. We have to realize that we have this identity that relates sine and cosine together. So if we take this Pythagorean identity and plug in the sine of 0.6, so we got the sine squared. So we've got 0.6 squared. The sine of theta is 0.6. You plug that in, you evaluate that. And now here you've got an equation to solve for cosine of theta. So we've got 0.36 plus cosine squared equals 1. Subtract both sides. Subtract 0.36 from both sides. Take your square root of both sides. And now we have the cosine of theta is equal to 0.8. And now we can plug both of those values in. We know the sine, we know the cosine. Find the tangent. So give number 4 a try. You're going to search for an identity that relates something you know to something you want to know, and use that. So let's check out number 4. Again, answering what do you want to know, and what do you know? What do you know? What do you want to know? I know the secant. I want to know the cosine, so I find an identity that relates them. I know that they are reciprocals of one another, so this one's really straightforward. Now I want to know the cosecant. This one might be a little tricky, but what we do know is that the cosine is 1/5, and the cosecant is the reciprocal of sine. So if we find the sine, we know the cosecant. So we can solve for sine in this particular case. So we've got sine squared plus 1/25 equals 1. So sine squared is equal to, subtract 1/25 from both sides, 24 over 25. once you take the square root of both sides, we know that the sine is square root of 24 over 5. Remember, that would be the square root of 24 over the square root of 25. And so the square root of 24 is actually reducible. So that's 5 on the bottom, square root of 4 times the square root of 6, right? So 2 root 6 over 5. And so your cosecant is the reciprocal of that, which is 5 over 2 root 6, which once you rationalize, 5 root 6 over 12. Finishing the last couple of them, the cosecant of 90 minus theta. Remember, we're going to look back at those co-functions from part 1 of this thing. So the cosecant of 90 minus theta is equal to the secant of theta. This one should be pretty straightforward. It's given to you in the problem. So that's just 5. And finally, the tangent. We need to know the sine and the cosine for the tangent. And what you would get is 2 root 6 over 5 over 1/5. How could we reduce that? 5's take each other out. So the tangent of theta would simply be 2 root 6. Briefly addressing the important ideas that we discussed in here, we looked at some of the fundamental identities. The fundamental identities you're going to find on this worksheet, on this reference sheet rather. We've got our reciprocals, our quotients, our cofunctions and our Pythagoreans. We'll get to all of these over the next couple of months, but this is just a small taste. What do you use them for right now? You can use them to find values of trig functions. In order to do that, find an identity that links what you know to what you want to know. All right, so in class, we'll revisit that a little bit more and have some time to go ahead and work on these check your understanding problems. The solutions are going to be posted in the PDF, but we'll have time to work on them and ask questions in class. Let me know if you've got any questions before then.